All right, so welcome to Geometry Notes 2.4. We're going to be talking about the Pythagorean theorem. So let's start with the triangles. So what is the difference between a triangle and a right triangle? So the difference between a right triangle and a triangle is a right triangle contains a right angle. And a right angle, of course, is a 90-degree angle that goes straight up and down. So how do you know it's a right triangle? Because they mark it with a square. And they mark the 90-degree angle with a square like that. So you know this is a 90-degree angle and that is then a right triangle. Or sometimes it could be up here. It could be a 90-degree angle. It doesn't matter the orientation, but we would know it's a right triangle because they include that little square at the right angle. So the parts of a right triangle, we have the legs. So that's a leg. And this is a leg, right? The two sides that make up the 90-degree angle we call the legs. Then the last side we call the hypotenuse. And that is the longest side. And it is always the side opposite the right angle. So always opposite the right angle, and we call that the hypotenuse. So the right triangles adhere to this principle, and it's called the Pythagorean theorem, and that is one of the legs, which we'll call A, if I square it and add it to the other leg squared, it's going to equal the hypotenuse squared. So A squared plus B squared equals C squared. So the leg would be A, this would be B, and the hypotenuse would be C, right? So A squared plus B squared would equal C squared. And it was discovered by Pythagoras in ancient Greece. And it has some pretty big implications, right? So it means that we can calculate distance, and we'll get into that in a minute. We can calculate distance. It means we can also calculate 90 degrees, which has huge implications for architecture as well as map making. And this has big implications on our civilization, our ability to create structures at 90 degrees, our ability to calculate distances on a map without actually having to travel. These were huge technological advances at the time. So, and all based on the Pythagorean theorem. So how does it work? So what we would do here is for every problem that we do, we're going to start off with the Pythagorean theorem, which is A squared plus B squared equals C squared. It's got a nice ring to it. And so the legs, here and here, these are my A and B. And then the hypotenuse is always C. The hypotenuse. So that's a big deal. The hypotenuse is always C. We can mix up the legs all we want, but if we mix up the hypotenuse, then we will get the wrong answer. So one of my legs here is 12, so I'm going to plug in 12. The other leg here is 5, and I don't know the hypotenuse, so I'm just going to leave that as C. And we take everything to the second power, add them together. So 12 to the second power is 144. 5 to the second power, that's the same as 5 times 5, so that's 25, equals C squared. So next, I'm going to add these together. I'm going to simplify. So 144 plus 25 is 169. That equals C squared. And this tends to mess students up sometimes, but the opposite of to the second power is to take the square root. So the square root of c to the second power gives us c. But what I do to one side, I have to do to the other. So if I take the square root of one side, I take the square root of the other. So the square root of 169 is 13. So that means this side here is 13. And that's our final answer. So let's try the next one here. This time, they give us one of the legs, and they give us the hypotenuse. So, and I know it's the hypotenuse because it's the one across from the right angle. It's the longest side. So I'm going to, again, start with a squared plus b squared equals c squared. Like I said, they give us one of the legs, so I'll say a is 6. I don't know b, so I'm just going to leave that as b squared. And I know c. C is 10. So I'm going to say equals 10 to the second power. So now let's simplify. So 6 to the second power, that's 36. And 10 to the second power is 100. So 10 times 10 is 100. So then I'm going to subtract 36 on both sides. Leaves me with b squared equals 64. So again, I don't want b squared. I want b alone on one side of the equal sign. So we're going to take the square root of b to the second power. Square root of b to the second power is just b. What I do to one side, I do to the other. So the square root of 64 is 8. So looking at our last problem, they want us to decide, is this a right triangle? Because right triangles will adhere to the Pythagorean theorem. So if this adheres to the Pythagorean theorem, then it'll work. And I'll show you what I mean by that. So we're going to start off with a squared plus b squared equals c squared. And I'm going to plug in what we know. So we know one of the legs is 5. We know the other leg is 12. And we know the hypotenuse is 13. So we're going to see what we get if we get a true statement. I'm going to finish this up down here. So 5 to the second power is 25. 12 to the second power is 144. And 13 to the second power is 169. So if this works, then I should get 169 equals 169. 144 plus 25 is 169. So this is a right triangle. I know it's a right triangle because we get a true statement. If we got something else, if we got 225 equals 169, then we would say, okay, it's not a right triangle because it's giving me this nonsense answer. But since we got a true statement, I can conclude that this is a right triangle. So going forward, I want you to complete all these problems. 1 through 8 were like the first 2 here. And then the last couple problems, 9 through 12, is like the last one we did. And feel free to check your answers on the side here. And good luck.